Hello, this is our last dimensional analysis problem. At the end of chapter 2 that you have hopefully been reading, it introduces the concept of density. In lab last week, we did some problems with density where we measured the mass, we measured the volume, and then we were able to calculate density. Now that we can do that, we know that our density is our mass over volume. And typically in our lab, we measure our mass in grams and our volume in milliliters. Okay. It can have different units, but that's our typical units. So in lab, we did measure the mass of an object, we measured the volume of the object, we divided the two values, and we determined the density. Well, now that it's already set up as a conversion factor form in this ratio form, we can use density as a conversion factor. And as a conversion factor, it allows us to convert from a unit of mass to a unit of volume, or a unit of volume to a unit of mass. So we can definitely use it as a conversion factor. So here's our first example of a density problem that's using density as a conversion factor. It says, what is the mass of 100.5 milliliters of a liquid that has a density of 0.862 grams per 1 milliliter? So dimensional analysis tells us to write down the information given. So we have our 100.5 milliliters, and then we know it has a density of 0.862 grams per 1 milliliter. By writing that down side by side, just reading it, writing it, if we were to take these two terms and multiply them together, like we would in a dimensional analysis problem, as we set that up, our milliliters over milliliters automatically cancel, and we're left with units of grams, which is what we're solving for. It says, what is the mass? So our mass in grams. So we didn't have to even think about the problem. We just wrote down the information, set it up as a dimensional analysis problem, canceling out our units. We have it set up right. So now we just multiply our 100.5 times our 0.862 grams, divide by 1, and we get our answer. And our answer, keeping with proper sig figs, is 86.6 grams. Our density has 3 significant figures. Our volume has 4, so our answer will have 3 significant figures. So dimensional analysis, easy. We just wrote it down, looked at our units, ended up with the units we wanted. We're done. So let's do another example. So here's another question. It says, what is the volume of 156.3 grams of a liquid that has the density of 0.862 grams per milliliter? So we write the information down. So we have 156.3 grams, and we know the density is 0.862 grams per 1 milliliter. All right, in this case, if we were to multiply these together as is, our units would come out as grams squared over 1 milliliter. That's not going to help us because we're solving for volume. We want our units in milliliters. So that what we can do is still use that density as a conversion factor, but take the reciprocal of it, or in other words, flip that value upside down. So we have 156.3 grams, put it in our problem, use the reciprocal of our density, 1 milliliter on the top, 0.862 grams on the bottom. Grams over grams will now cancel each other out, and we're left with the units of milliliters, which is what we want. So we once again didn't have to think too much about this problem. We wrote the information down. Notice that our units weren't coming out right, so we flipped our conversion factor upside down, canceling out our units and ending up with what we want. That's a good way to double check all your conversion factors, is make sure you write out all your units, and if your units come out right, you know you have it set up right. So now when we do that, we come up with 181 milliliters as our answer, keeping with 3 significant figures. And that's the end.